we've looked at some of the climate profiles, we'll take a look here at some of the major landscape profiles, because there's not only climate information that we want to look at, but also biogeographic type of information. And so the two major types of landscape profiles that we have are the humid and the arid. So based on whether an area was humid or arid, it's going to change the way that the overall landscape looks. So in a humid landscape, you tend to have quite rounded hills. And whenever there's a valley involved in a humid climate, you'll always get a key point near the top. The key point we'll go over in just a minute here. But these landscapes have been shaped with water. That's why they are as rounded as they are. And the key points are simply where the hillside turns from convex to concave. So every hillside will have that turning point where it goes from convex to concave, and that is our key point. Now, this key point isn't only on each hillside, but also within a valley as well. So when we look at the way that a valley is shaped, a valley is a V shape that's going usually up to the point where there is no valley anymore. And as that valley is coming up in elevation, when that valley floor is coming up in elevation, it too is going, so from the bottom up, it's going from concave up to convex as the valley itself is going higher up. And so this key point here is extremely important in our designs because it is the highest place in which we can hold water easily on our properties. And what we really want to do in this case is actually this point will always be the back side of our water storage. So for example, you may put in a dam wall. This is really extreme slope here that we've got according to my drawing, and the water would fill up. Put the cast back on my markers properly, this would work better too. And the water would fill up like this, so that the back part of your pond is actually going to be where that key point is. So there's only two possibilities of things that can exist in the top of a valley. It can either be a hilltop or it can be a ridge. It's really just that simple. There really aren't any other possibilities of things that can exist at the top of a hill or the top of a valley, pardon me. So there's other features in the landscape that will very often allow you to hold water higher up on a property, but they aren't always there. So for example, you might have a saddle, like where the hill actually kind of has a little bit of like an indent in the top of the hill, and you might be able to store water up there. Or perhaps on the ridgeline itself, the ridgeline might be divided and have an area where you can dig into it and store some water as well. But you can't depend on those things being there at all points in time. So the key points are the only things that we can always rely on and depend on in our landscapes. And these exist on every single hill in a humid landscape. Every single hill follows this same kind of convex to concave, where there's this inflection point. That is our key point. Also, humid landscapes are very often acidic. And that's because when it's humid, it tends to be wet. And when there's a lot of wetness, things tend to go anaerobic, meaning without oxygen. And therefore, they turn acidic for the most part. So if we look at the difference between that and the arid landscapes are quite angular in fashion. So wherever there's any sort of peaks or hills of any sort, they're all quite angular. So if you think about hoodoos near Drumheller, Alberta, or you look at even sand dunes in the desert, they're all very angular and very sharp points because they were shaped mostly by the wind and that kind of erosion as opposed to being shaped by water. So the major features of the arid landscape is that we don't want any open water in these areas. So you're not going to be putting in a pond, for example, in an arid landscape unless it is extremely shaded. You're going to want to try and soak a lot of that water in and hold it in with a lot of mulch. So all of your water has to be shaded, and you're going to want to try and reduce the evaporation as much as you possibly can. You're going to want to try and soak whatever water you have down into your soil. And this landscape will respond extremely quickly to our actions if we do the right thing, because we have so much sunlight available in these kind of climates. So another thing that we can do in these arid landscapes is that we can catch a lot of the airborne nutrient that's coming in on the wind, and we can use that to add a bunch of fertility. Because there's so much wind erosion that's happening, we need to trap as much of that nutrient as we can and prevent it from blowing away. So these areas here, they can still be forested. It's not like they're always really, really barren landscapes, but it's a very dry forest, or you'll get a lot of cactuses. For example, the Seguro cactus can be over 40 feet tall, so you would consider that a tree in those kind of landscapes. So cactus originate in the Americas, but they're not simply a feature of an arid landscape either, because they can go right up to snowy areas in Canada. I know we have some prickly pear cacti right near us. And they can go all the way down to the Amazon. So cactuses are very, very far-reaching, but generally we see a lot of them in the arid climates. But they've adapted to so many different climates that we think of them as a desert plant. So in this kind of climate where we have very arid conditions, this is where we want sand and silt, rock-filled ponds without any open water. So we want to catch all of the water off of hard surfaces in these kind of climates. So off of giant rocks or mountaintops. And this is where we want to talk about ponds that we can shade, swales and gabions and rock dams that leak through all the water but hold all the nutrient behind. So these are just some of the techniques that we can use when we're working in an arid landscape to help reduce the evaporation of that water but still collect a lot of nutrient. And in contrast to the humid landscape, arid landscapes tend to be alkaline, not acidic, because when things are extremely dry, they tend to go more towards the alkaline side of things when you're looking at the pH. So this brings us to a bunch of our minor landscape profiles. So the two major landscape profiles we have are the humid and the arid, and the minor landscape profiles that we have are the volcanic, we have the high island, low island, flatlands, wetlands, coasts, and estuaries. So we have quite a few minor landscape profiles. So just the same as we can fit ourselves all into the major climates of temperate, tropical, and dry lands, we can also fit ourselves into a humid landscape or an arid landscape. And then within those two major landscape profiles, we can categorize ourselves into one of these minor ones typically as well. So when we're looking at these ones here, if we take a look at our volcanic slopes, our volcanic landscape profiles, they are always of the same angle of repose, which is quite interesting. So if you look at a volcano anywhere in the world, they will always be the same angle in this sense because of the way that they're all created by the settlement of the volcanic ash. And that's how we identify them as a volcano instead of a mountain. They're very, very distinctive. And they're usually alkaline, especially if they're active, even though it's lush and green and humid. And this is because of the large ash deposits that are found here. They are quite steep, so that always kind of poses a bit of an issue when we're trying to design things on a volcanic slope. And on a contour map, they simply look like a bunch of kind of wavy concentric circles with streamlines coming out of the center of them. So settlements, when people were trying to establish settlements on these volcanic slopes, they were very often positioned right next to a streamline. And they basically would be able to put enough land into production that they'd be able to feed their tribe. And that's not that easy to do when you have a very, very steep slope. So on these volcanic slopes, they didn't have a tendency to plant right at the top because there was a lot of natural forest at the top, and it was culturally taboo to actually plant at the top of these volcanic slopes. It was a natural forest that very often in most cultures would actually carry the death penalty for disturbing it. You would pretty much just get tossed into the volcano and sacrificed to the gods if you tried to remove that natural forest. So a type of this kind of system where they're making settlements along the side of a volcano, in Hawaii, that type of a settlement is called an ahuapa. I probably butchered that, but at the top of the volcano is farm forestry, which is only ever cut with very grand ceremony. So it might not even be this top forest section. They would actually put in some farm forestry up at the top here, which would be cut during a ceremony where people were maybe building a new house or they had to build a canoe or something like that, and there would be quite a bit of reverence around actually harvesting those trees. You can't just cut it whenever you want. And below that would be the productive trees. So this would be maybe your fruit trees, your nut trees, things like that. And so very often, like in Hawaii, for example, there would be things like kukui nuts, otherwise known as kind of candle nuts. And they wouldn't harvest them right up at the tree. They wouldn't bother going that high up on the volcanic slope because it is steep. And it requires a lot of energy to do that. So what they would do is they would wait for all of these nuts to actually get washed downhill, and that's when they would harvest them. Then they would start to have the water kind of redirected out on contour in a swale-like fashion, where they would have a bunch of little ponds. I really changed that lid so my blue is actually blue. Okay. So there'd be ponds. So the water would be redirected, and then there would be ponds all along these lines here that would help saturate into the landscape and provide water for things down below. And so these ponds, they would also have paddies where they would grow things like taro, and there'd be lots of nutrients and soaking going on in this particular area. So they would have anywhere from 1 acre of mulch to 1 acre of taro, all the way up to 5 acres of mulch for 1 acre of taro. So these were huge, huge, huge sponges in the landscape that were holding on to a bunch of water for a lot of these plants. And the next area, as we go down, would be the village gardens. So this would be kind of their annual crop garden, kind of an idea, things that they would be picking constantly for meals, probably some medicine and things like that in there as well. And then the next is actually just the village itself. So they would have a bunch of houses, huts, all positioned below the village gardens. And this village, they always had to make sure that it was set quite a ways back from the ocean because of tsunamis and all of that kind of potential. So there's still a little bit more volcano left to go here before you get down to the ocean. And so typically, in between this village and the ocean itself, there would be actually a tsunami buffer. So this would be typically about 150 meters where they would plant, should probably make those look more like the actual trees here too. So this would be like palm trees, just lots and lots and lots of trees to try and protect their village from any sort of tsunamis. And they would redirect a little bit of spring water at this point because the spring water would start to kind of come up from the beach and everything too. So they would try and use that to their advantage. So small ponds, once you got down to the ocean level, they would put in small ponds where these springs would come up to try and catch some fish. And they would also, once they put in these small ponds at the bottom, they would also put in larger ponds kind of right within the ocean. So they would make almost like walls in the oceans, kind of like a double wall system where the fish would come in but not really be able to get back out. And so these large holding ponds would be where they would have a bunch of fish that they could hunt or that they could catch at their disposal. So since volcanic slopes will always be steep, because they always have that same angle of repose, it's very important in this situation to consider our design from the top down, just making use of all that nutrient moving down the hill. And it's an important note to make too that whether you're in a humid landscape or an arid landscape or any of the above, chances are you're always trying to stop and spread and sink water into the landscape, regardless of which type of landscape profile you have.